the problem we're going to solve right now states as the following. A common laboratory laser produces 3 milliwatts of power in a beam whose diameter is 1 millimeter. How strong is the electric field in the beam? The first thing we want to do is we're going to want to solve for the area of the beam. All right. So the area of the beam, since it's circular, is going to be pi r squared. Now our diameter is 1 millimeter, or we can say it's equal to 1 times 10 to the minus 3 meters. If that's the diameter, then the radius is going to be 0.5 times 10 to the minus 3 meters. And so our area is pi times, now our radius, which is 0.5 times 10 to the minus 3 meters squared. Our area then is going to be equal to 7.85 times 10 to the negative 7th meter squared. So that's going to be our area. Now our electromagnetic intensity is given the symbol S, and that is equal to our power divided by our area. Now our power is, we're going to put this in watts, so this becomes 3 times 10 to the minus 3 watts divided by the area we just found. And that's 7.85 times 10 to the minus 7th meters squared. And so once again, our S is the electromagnetic intensity. Now we do that calculation, we get 3820 watts per meter squared. Now ultimately what we're looking for is we're looking for the strength of the electric field. We're going to use the Poynting vector. The Poynting vector is that S is equal to c, which is the speed of light, the permittivity of free space, times the electric field squared. Now we can solve this for the electric field is equal to S, so this would be electromagnetic intensity, divided by c, which is the speed of light, divided by the permittivity of free space, and the square root of all that. So now we just simply start plugging into this. So this gives us, oops, got ahead of myself, 3,820 watts per meter squared divided by our speed of light, which is 3 times 10 to the 8th meters per second, times our permittivity of free space, which is 8.854 times 10 to the negative 12th. This is going to be a Coulomb squared per Newton meter squared. And then the square root of all of this. And when we do this calculation, we come up with 1,200 volts per meter, which is the units of an electric field. If you have any questions, please let me know.